Hello everyone, I am Sai Sairam from the Machine Learning and Vision Group of IIT Hyderabad. I am presenting our work titled ARUBA, an architecture-agnostic balanced loss for aerial object detection. This is a joint work with Monish Keswani, Uttaran Sinha, Nishit Shah, and Dr. Vineeth Balasubramanian. In this work, we aim to solve the severe size imbalance in drone-based aerial object datasets. Existing works for solving size imbalance largely proposed architectural modifications to view objects at different scales. We, on the other hand, propose an architecture-agnostic loss reweighing strategy that can be applied as a plugin on top of any object detection model. To the best of our knowledge, this is the first such loss-based approach to solve size imbalance in this domain. In recent times, drones have shown immense potential in numerous disciplines, which encouraged the computer vision community to work extensively on vision from drones. We observed that the size imbalance is severe in aerial object datasets when compared to natural object datasets, as shown in this image, which motivated us to address this imbalance problem of drone-based aerial datasets in this work. It is intuitive to see that the performance of an object detection model on instances of a given size would have contribution from object instances of neighboring sizes. Keeping this in mind, we designed a simple pipeline of 4 stages to calculate weights for an object based on its size and class. Given a dataset, we first segregate the object instances class-wise. We then apply a Gaussian amplification on the size distribution to consider the effect of neighborhood. We subsequently use a clustering approach to assign weights to object instances based on their sizes. Finally, we reweigh the loss based on size to suit our problem. For a given class, we obtain Gaussian amplification by convolving a predefined Gaussian kernel of width W with the size distribution. This size distribution of a given class is divided into m bins as shown here. For more details about the Gaussian amplification process, please go through our paper and supplementary material. Inspired by a previous work, we define EYS as the effective number of objects of a class Y belonging to a size cluster S, where beta is a hyperparameter and GA is the Gaussian amplification process. For an object detection model, we calculate the loss by multiplying the obtained weights with the regression loss and adding it to the classification loss. We used 4 different aerial object datasets for our experiments. For evaluation, we follow the standard COCO format following the previous work as shown here. Our method is able to obtain consistent performance improvement on all the 4 aerial datasets as shown in these tables. We also provide qualitative results to illustrate the usefulness of our proposed approach. This figure shows the predictions of the baseline and our model on images of HRSC 2016 dataset. Top row shows how the baseline fails to detect a few objects, and the bottom row shows how our loss function helps the baseline correctly detect additional small objects as shown in the yellow boxes here. This image shows how our model reduces the false positives on images of DOTAv1.5 dataset. Top row shows that the baseline struggles while predicting small objects and results in false positives as shown in the red boxes, whereas the bottom row shows how our model is able to detect small objects accurately because of our effective loss reweighing strategy. We are grateful to the Ministry of Electronics and Information Technology and Ministry of Education, Government of India, as well as IIT Hyderabad through its MOE DRDO Fellowship Program for their support to this project. If you are interested in our work and want to understand it in more detail, please scan this QR code and read our paper. If you have any questions, feel free to contact us.